Alright, for this video we're going to continue with our square root function, and we're going to look at the inequalities, or actually graphing the inequalities here. So our essential question that we're going to answer through this video is, how do we graph square root inequalities? Alright, so in addition to graphing our radical or square root functions, which we just did using our transformations, our horizontal shifts, vertical shifts, stretches, and compressions, we can also graph radical inequalities. We're going to use the same procedure that we used for graphing our linear inequalities. So let's take a look. We have the inequality y greater than the square root of 2 times x minus 3. So the first thing I want you to do is I want you to focus on the transformation. Nothing is happening inside of the radical, so no changes to the x. However, we are subtracting a 3, so remember that is your k. And we are multiplying the 2 by the function itself, so that is your a. So this is greater, a is greater than 1, so that is our stretch. So what we have is, for our transformation, is we have a k of negative 3, so we are going down 3 on the y-axis, and then we are going to stretch it. Remember, you're going to stretch it vertically, so your little curve is going to be pulled up. So the transformation down 3 and a vertical stretch of 2. So remember, what this vertical stretch of 2 means is we are taking those values of y and we are doubling them. So we're going to just take a look at the related equation, and we're going to make our table of values. You know what this is going to look like, but using the table of values will give you a more exact graph. So here's a set that I've used. You notice the number I've used. When I sub in, I get back these numbers. You notice 1, 4, and 9. Why did I use a 1, 4, and 9? Because they are perfect squares. So if I put, for example, my 1 in here, I know that the square root of 1 is 1. So 1 times the 2 would be 2, and minus 3 gives me back that negative 1. And then I go to my next perfect square, which is 4, because I know the square root of 4 is 2, and then 2 times 2 is 4. So all this is 4 minus 3 gives me the 1. And then I take another perfect square of 9, so I know the square root of 9 is 3 times my 2 is 6. Then I subtract the 3, and I get the 3. So now you've got a pretty good look at what that graph is going to look like. So you're going to go to your coordinate plane. Now, since we're working with inequalities, we have to pay attention to our symbol, and our symbol in this case is a greater than. So there is no equal sign, so we will use a dashed curve, and greater than, we are going to shade above it. So here's what the graph is going to look like. We're down here at our negative 3, and we plot those points that we used, and we get, you see that he is actually stretched. He has a little steeper curve here, and then we're going to shade above it. So here's our shading above it. You notice that we stopped at the y-axis, because remember, the value of x, since it's under the radical, it cannot be negative, so we stop our shading there. And as always, you want to check a point to make sure. So you pick a point up here in the shaded area and put it in your inequality to make sure it works. So if we chose 0.10 and we subbed that in, of course, why did we use a 1 here? Because it's a perfect square, right? So the square root of 1 is 1 times our 2 minus 3 is a negative 1, and we see that that checks. Let's do another one. We have y greater than the square root of x plus 4. All right, focus on the transformation. This time we are affecting the x. We're actually adding a 4 to it. So this is your h. So we are having a horizontal shift. And remember, we look at this as opposite, so we will shift to the left. Now that we know that, now we're going to look at it as just an equation, and we're going to make our table of values. This time, we're going to have to choose x's that will actually give us a square root. And here they are, right? So we want these to come out as perfect squares. All right, so if I put in a -4, well, what's going to happen? -4 plus 4 is 0. So that one's easy. Now, my next perfect square is a 1. So what could I put in here to give me a 1? And that's a -3, right? -3 plus 4 would be 1, and so the square root of 1 is 1. My next perfect square is 4. What am I going to put in here to give me a 4? Well, obviously a 0, right? 0 plus 4 is 4, and the square root of 4 is 2. My next perfect square is 9. So what does x need to be to give me a 9? And that would be our 5. 5 plus 4 is 9, and the square root of 9 is 3. So you know what your transformation is. You know that your curve is going to be shifted to the left 4, and you've got these values here to pinpoint that. And so go to your graph. Pay attention to your symbol. Your inequality sign is a greater than. So again, we will use a dashed curve, and we will shade above. So here it is. Here's the -4 and down here, -4 and 0. Our 0, 2, so we're crossing the y-axis here at 2. And here is our dashed curve. And again, it was greater than, and so we shade above it. We stop at the -4 because our curve starts at -4. So as you shade, you will only shade from -4 on into infinity. Again, pick yourself a point in the shaded area just to do a quick check. Make it easy on yourself. Choosing a 0, 4. So square root of 0 plus 4 is 2, and 4 is greater than 2. All right, I've given you 2 inequalities that I want you to graph at home. I would prefer you use graph paper, but if not, you have those little graphs I gave you before, or you can make yourself a sketch. Pay attention to the symbols as you do that. As you put in those values of x, remember you want a perfect square coming out of that, so it makes it easy to graph. We will check these at the beginning of class, and also do not forget to fill out your whisk.